one last thing right here, and then we can send you off. I put just a few weird values in for the button in. And when you simulate here, up till now we've been simulating pretty much purely combinational logic. So when that first dialog comes up, we've gone over and we've clicked on the boxes as combinational. This time when that box comes up, there'll be the clock signal. If you named your clock signal clock or CLK or something, Xilinx will look for it. And it's pretty good about finding things if you name your clock signal something appropriate. And you want to click that, and it will automatically draw your clock signal for you. You can click on combinational, but then you have to draw each clock transition. You have to draw this whole this long square wave here. Okay. Let's see. In this simulation, when you go for a simulation, to test this, okay, let's go back to this just for one more second. To test this, remember our numbers were, 100,000, 250, and 100,000. You could simulate that. You'd have to click there and have it go through an awful lot of time to complete a simulation with those numbers. So when I have some numbers like that, I replace them with little numbers so I can check my code. And right here, I'm looking for 3 clock cycles. 3 clock cycle generated, and each of those clock cycles should be 5 of the clock signal. So that's why there's only 3 clock signals here. After a button in, you get 3 clock signals. And this right here, note that it doesn't start immediately because it's waiting for the button to be released. And then when it sees the new button pushed, and it starts a new series there. So just to make sure that the clock explanation was clear, let's do let's see, door bell test 3. So this is what I was talking about here, the single clock, and it gives you a choice of your signals, but very often it gets the right one there. Actually, I don't know if it's smart in thinking of that, or it just happens to get that signal because it starts with a C. A button starts with a B. Yeah, I think it must look for names that look like clock. Okay, so far we've been clicking on that, but if we do that, that's fine again, but you will have to draw your entire clock signal, that big long square wave. And just to put a little more information into a smaller area, I lots of times change the values here, and I add another 0 here or whatever to get more information into a smaller area. Okay, and shoot, I really wish I could hear your questions. For next week, what we're going to be doing is we're going to be building a little transceiver. So we're going to build a transmitter and a receiver, I should say. Not a transceiver necessarily. And we're going to work off of this example. So your transmitter is going to be kind of like your doorbell circuit here that sends out a signal, and your music player is going to receive that signal, interpret it, and do something. Okay, and I think that's it. Have a good Thanksgiving, and look for a few more things posted right at the end of the week to bring to class. But remember, bring your Xilinx board and your computers so we can play with the boards a little bit in class. Okay, night.